It's Eduardo here, and in this video I'll talk about how to fix broken tests and debugging in general. A note I want to make before I start is that there isn't a given set of formulas to fix any broken test. There is a creative step to debugging and fixing tests. So what I'm going to present are just a set of tips and tricks to help you out. And for this video, I'm gonna use the Java kata that I've written called the surfing kata. I'm gonna start halfway through the exercise, which is where it starts to get interesting. So after the second part of the exercise, if you want to replicate what I'm gonna do in the video, what you should do is go to the link here and then go to Java katas, then commits, and then look for the commits on the 20th of June of 2018, and then look for the commit message called code for test for second IC, and click on this link here. And what you want to do is check out this commit number. So I've already done that, as you can see here. So let me just put that there. So check out this commit if you want to do this at home. Okay. Okay. If you want to read more on the surfing kata, you can just visit the GitHub link in here. Okay. Otherwise, I'm just going to start now. So I will give a brief summary of what we've done so far up to this point. So in the first part of the kata, we have written a surfing app that pops up a notification on our phone on two different set of ideal weather conditions. And if the weather is not ideal, then we should get no pop-up on our phone. And this gets reflected on the tests that are written here. So should notify to go surfing on the first set of ideal weather conditions. So we get a notification on the notifier app. And then we also have should notify to go surfing on second set of ideal weather conditions. So again, we got a notification when the temperature is ideal, and in the first case we got the notification because the wind speed was higher. And then we also had a negative test case, so should not notify to go surfing on non-ideal weather conditions. So if the temperature and wind speed are low, then we expect no interactions with the notifier app. So that was the first part of the exercise. And then the second part of the kata asks for a pop-up with a different message and a vibration on our phone to be created when the weather conditions for surfing are excellent. This gets reflected on the next test case. So the temperature and the wind speed are both quite high. So in this case, we get a notification and a vibration on our sent through our notifier app with a different message. Cool. So that's really all the background you need for the exercise. And then we can start with the third part of the kata, which is where things start getting interesting. So the third part of the kata asks us to limit the times when we get a notification to being, say, 12 o'clock, 1 o'clock, 2 o'clock. And that's because otherwise we'll get a notification every second because our app is running on the background of the phone. And the exercise asks us to use a clock app for this. So as always, I'm going to write the test first, and then I'll proceed to writing the code. Okay. So because I've been asked to use a clock app, I'm going to create a instance of a clock app. I'm going to make it a mock because I want to have control over its behavior. And I'm not testing the clock app, I'm testing the surfing app. I'm going to make it a constructor argument because I need the clock app for my surfing app to function. Okay, so it's going to do that for me. and I'm ready to write the first test case. Which is should notify on the hour on good weather conditions for surfing. Okay, so as always, there's going to be a given, a when, and then components to our test. On the given, I'm going to set some ideal weather conditions, but I'm also going to set up the time of our clock. So the clock app has a get current time method that returns a local datetime. So we can see here, I'm going to say when we try to get the current time from the clock app, then return a local datetime of say 1 o'clock. Don't really care about the date, so I'm going to say it's today, and local time of say 1 o'clock. Cool. So that's sufficient for the given part. And on the when is the simplest part of our test. So surfing up alert on good weather conditions. So because we're trying to alert on good weather conditions at 1 o'clock, then we are expecting a notification. Perfect. So that's the positive test case. And then let's write a negative test case where we don't get notified. So should not notify past the hour on good weather conditions for surfing. So in this scenario, the time is going to be 1 minute past the time. And I expect no interactions with the notifier app. Okay, perfect. Now that I've written the test cases, I'm going to run the whole test. Okay, so all of the test cases pass except for one of them, which is the last one. And that's reasonable because the first new test case behaves just like our previous test cases. And the second one fails because we haven't embedded the clock app logic into our surfing app yet. So let's read the exception, the error message anyway. So it's telling us that there were no interactions wanted here, so on line 76. So we didn't want any interactions on the notifier app. However, it found this interaction. So even though we didn't want any interactions on the notifier app, somehow the test reached the line 22, and the notify method got invoked on the notifier app, which was unexpected according to this test. So we're just gonna fix it by writing the code. Okay, so we got the clock up. Let's create a field for it. And then let's say if the minutes is not 0, then so if it's not on the hour, then we want to exit the program early. Okay, so I think that should be all the code that I need to write. I'm gonna rerun the test. Okay, so this is an interesting situation because the two new test cases have started to. However, our previous test cases are now failing. Okay, so here's my first tip. When multiple test cases start to fail, just pick one, anyone, and focus on it. So let me write that down. Okay, so I'm gonna pick the first one here, um, and I'm gonna look at the test, and then I'm gonna go to the code and try to reason out why it's failing. Um, well, actually, the first thing I'm gonna do is read the error message. So a null pointer exception is being thrown. So when I see an exception is being thrown by a test, I always look at the stack trace. I look at the immediate line. So the null pointer exception stack trace is telling us that there is a null, well, that the null pointer is being thrown on line 18 of the surfing up class. So for a null pointer exception to have been thrown here, either the clock up or the current time of the clock up must have been null, because if the minute component was null, then the comparison wouldn't throw a null pointer exception. So here's my next recommendation. Whenever you get an exception, always look at the stack trace and look at the first line to see where the exception is thrown. Unexpectedly. To reason out what the problem is. Okay. Another tip, or actually something that you should realize, is that the test cases, the failure or non-failure of test cases, is something that's reproducible. So if I keep rerunning the tests, I'm going to get the same results. Um, the thing that you have to note about that is that the test cases used to pass whenever I didn't have these lines of code. Right? But as soon, yeah, as we can see, as I add these lines of code, then the test starts failing. So that's something else to bear in mind. When test cases start to fail, you should only focus on the lines of code that you've changed. And in this case, we've only changed the 3 lines of code. So both the exception and the fact that these are the lines of code that have changed are pointing us to the fact that this is the line that's causing us trouble. So that's the other hint. Um, focus on the lines of code that have changed, right? Because that's where the problem is going to be. Okay. If I was still unsure as to why the exception is being thrown, then I would start debugging. So I'm going to put a breakpoint there. And I'm going to debug the test case. Cool. So on here, I'm going to use the variables. I'm going to see that it's still collecting data. Right, so I should see that the clock up is not null, so that's not going to, get current time is not going to throw an exception. So let's see what the current time is. So I can press Alt F8 when highlighting a block of code to evaluate an expression without actually um, executing that line of code. Okay, so that the current time is actually null, so that's our problem. So if we call get minute on that would be, oops, that would be our cause for the null pointer exception. Fine. Now that we've identified what's null, and that's the current time, then we have to reason out how can that have been null. Um, so in this case, the current time comes from the clock up, which we know is a mock. So that means that we just simply haven't set up the clock up to have a time, to return a time. Okay, so when debugging, it's important to look at the variables box, but then you can also use the frames box. So it gives you the stack trace of the program that you're executing. So right now we're on line 18 of the surfing up class on the alert on good weather conditions method. If I click here, just one below, it takes me back to the test where I came from. And yeah, I can see here that I haven't set up an expectation for the clock up to return any time. So right, so I've already found out what the problem is. And that's probably the same. We've probably got the same issue on every test because we haven't set up the time on any of our old tests. So I'm going to copy the clock up setup from one of our new tests. And I'm going to say that by default, I want it to be a reasonable time. So 1 o'clock. And I'm going to put that on the setup method so that I don't have to keep repeating this line of code on every test. So by default, it's going to be 1 o'clock on our test. Okay. So now I think that I should have fixed my test. I'm going to run it again. Cool, so now it passed. Let me write the tip before I forget. When you're unsure of the cause of the broken test, debug, and then pay attention to the variables box and the frames box while debugging. So make use of them rather than pay attention. Okay. So let me run now I fixed one test case, so let me run the whole test again. Okay, so we have fixed every test. Our intuition was right. The clock up setting was missing from all of our test cases. So that's actually another. This isn't so much of a hint or a tip as much of a note. So when multiple test cases start to fail suddenly after a change, the chances are that they're failing for the same reason. Start failing after a code change. Cool. So we've just finished the third part of the exercise, so we can now jump to the fourth part. And the fourth part of the exercise asks us to do three things. So the first thing is it asks us to take the location of where our user needs to go surfing from a GPS app that tells us where the city is nearby our user. So let me write that down actually. So for the fourth part of the kata, we need to get city location from the GPS app. We also need to change the message of the notification to contain the name of the city. And then it also asks us to not get a notification when the city doesn't have a page, which makes sense. Cool. So let's take care of those 3 points on our tests. So similarly as before, I'm going to create a GPS app, and it's going to be a mock. I'm going to add it as a constructor argument for the surfing app, and now I can write the new test cases. So should get a city nearby from a GPS app. And notify to go surfing on good weather conditions, for example. Okay, so as always, given when and then. I'm going to say that there's good weather conditions. I'm now going to set up the expectation on the GPS app location. So the GPS app has the get nearby has the get cities nearby method that gives you a list of cities nearby the user. Okay, so I'm going to say that the user is for this test nearby Barcelona. Okay, and Barcelona has a beach. So given that the user is in Barcelona and there's good weather in Barcelona and the time is 1 o'clock, when we try to alert on good weather conditions, or when we request the surfing app to alert on good weather conditions, then we should expect a notification. This time we're expecting it to also say, go surfing today to Barcelona. Okay, and then so that's taken care of the first 2 points of the fourth part of the kata, and then we need a case where the user is in a beachless city, so we should not get a notification on that case. So let me copy that. So should not notify to go surfing when user is in beachless city. Cool. So for this test scenario, we're going to say that the user is in Madrid, and Madrid doesn't have a beach. So even though it's hot, we expect no notifications. Cool. So I've written my 2 new test cases. That should be it. So I'm going to rerun the test. Okay. So in this case, the 2 new test cases are failing. I'm going to start with the first new test case. The first new test case is failing because we wanted the argument of the notify method to be you should go surfing today to Barcelona. However, we were notified with the message you should go surfing today. So yeah, it's expected this failure. We'll fix that. And then the second new test case is is failing because we wanted no interactions on line as described in line 110. However, somehow the test executed line 29, which invokes the notify method on the notifier app. Okay, and that all makes sense because we're not using the GPS app yet on our code. So let's take care of that. Let's first create a field for the GPS app. And then we're going to get the nearby cities from the GPS app. We're going to iterate over those. And for each city, we're going to execute this code. So I'm going to lift and shift this up here. Okay, so instead of getting the weather conditions for always for Waikiki, we're going to get them for the city ID where we're at. But then we're also going to include the name of the city in the message that gets printed on the notification. Okay, so I think that should be it from a code perspective. So I'm gonna again rerun the tests. So I've made that mistake here on purpose, but we'll get to that soon. Okay, so this time we've got different failures. Some of them are red and some others are orange. The red ones are ones where an exception has been thrown. We've dealt with an example of those before, so this time I'm going to pick one of the orange ones. And the orange ones just indicate a mismatch of expectations. Okay, so again, let's use the tips that we've talked about. So we need to focus on the lines of code that have changed. In this case, it's a little bit harder because we've changed quite a few lines of code as indicated by the green area, but mostly what we've added is the GPS app. So we know, or we should kind of start to realize that it's going to have to do something with the GPS app, really. And then let's also use the error message to help us understand what's happened. So on our test, we wanted the notifier app to be invoked, but as described on line 42, but actually there were 0 interactions. Okay. Again, I'm going to focus only on one test case, and that's this one. So I'm going to run it on its own, just so I can ignore everything else. Right. So yeah, so we're expecting the notify method to be invoked on the notifier app. However, it's telling us that there were 0 interactions with this mock. Okay. So there's no exception, so we can't use the stack trace to help us. This time we've changed quite a few lines of code, so that's also not going to help us a lot. So let's fall back on debugging. So we've got the breakpoint from before. Okay, so we're here, and the clock up should have been set on the setup method. Okay, and that takes us here, perfect. And then again, if we look at the variables box, we should see that the cities nearby is an empty list. So if the list is empty, the code or the cursor is obviously going to jump outside of the for loop the next time I execute it, right? So I need to figure out what's there, and that's a problem. We would expect this test to go inside the for loop. So we need to understand why the cities nearby list is empty. And the cities nearby come from the GPS app. And the GPS app is a mock. So that's already telling us that we haven't set up the expectation of the GPS app. So we've got a very similar problem as before where we hadn't set the default time for the clock up. In this case, we haven't set up the default city for all of our previous tests. So again, I'm going to go to the frames box. I'm going to click on my test just to confirm that I haven't set up the default city. So yeah, I need to do that, and I will do that to fix the test. I'm just going to copy the line. So by default, we as parts 1 and 2 of the kata describe, the user is in Waikiki, which does have a beach, and the ID of Waikiki is 55. Cool. So hopefully that will have fixed the test. I'm gonna rerun it. I'm gonna redebug it. Okay. So we're back on the clock up. It's 1 o'clock, so it doesn't exit early. And then this time when we call the get cities nearby, we've got a city, one. Okay, that's perfect, and that should be, so I'm gonna inspect inside, and that should be Waikiki, which has a beach, and the city ID is 55, perfect. So I should just, okay, that's all going smoothly, so I'm just gonna let the program run. Okay, wow, okay, so the test is failing, so let's see why. Okay, it's telling us that the arguments are different. So it's saying that the test wants the notification message to be you should go surfing today. However, the actual invocation, what actually happened when running the test is the actual notification message was you should go surfing today to Waikiki. Ah, okay, that's right. And that's because we've changed the message uh, that we're expecting. So let's add the to Waikiki everywhere. Okay, that's that. I think that should have fixed it. So I'm just gonna run rather than debug the test this time. Cool, so it did pass. Perfect. So let's run the whole test. Again, see if that fixed any other tests. Okay, so it did fix a few of them, which again highlights our previous uh, note, which is if a lot of tests suddenly start failing, then they're probably failing for the same reason. So by fixing one of them, we fixed quite a few of them. That's nice. Um, but the two new test cases are still failing because of a null pointer exception. So I'm going to focus on the first one, and going to follow the tips that we've talked about. So there's a null pointer exception that's been thrown on line 31, which is this line. So that's telling us that the weather conditions object must be null, because this is the only method invocation in this line. And the weather conditions comes from the weather app, which we know is a mock. So somehow we know that we've set up the weather app given incorrectly. Um, so let's debug just to see how. And I'm going to put the breakpoint on here. Okay, so it's reached that point. I'm just going to fast forward here. Okay, and we got the weather app. So I'm gonna just step. Okay, yeah. So just as we said, the weather conditions object is null. Um, but that's unexpected because I do think that we've set up the weather on our test. So I'm just gonna verify that by going into the frames and clicking here. Yeah, and I have set up the weather um, for CTID 55. So I'm gonna go back again to the test. And I'm gonna inspect the city, and I'm gonna look at the city ID because I'm expecting that to be 55, or it should match. Okay, hang on. The city ID of Barcelona is 1. And you know, there should be a light bulb moment here where we realize that we didn't set up the weather conditions for Barcelona, but we set them up for Waikiki. We made a mistake here. So let's change that one. And actually, we've done the same mistake here for Madrid. So let's change it too. Let me rerun the test and see if that fixes it. Okay, so that fixed that test case. So let's run the whole test suite again. Okay, unfortunately, it didn't fix the last test, and let's see why. So it's still got the same error message, so we didn't want an interaction online as described in line 111. However, there was an interaction on line 36. Okay, so I'm gonna play dumb. I'm gonna say I don't know why that happened. So I'm gonna again put a breakpoint at the beginning and debug the method or the test case. Sorry. Okay, so I'm expecting this to continue. Perfect. And then I'm expecting the cities nearby to be Madrid with city ID 1 and it doesn't have a beach. Perfect. And then when I get the weather up, I'm expecting the weather conditions to not be null. Perfect. So there's good weather conditions. But actually, now I should realize that the what I'm expecting the code to do is to exit or to skip Madrid because Madrid doesn't have a city. But I haven't actually put that logic here in the code. So the code will just continue and it will actually notify. So at this point, I know what the error is. So let's put the logic for that. So we only want this code to execute if the city has a beach. Okay. So because I'm pretty sure that that will have fixed the test, I'm gonna just run the whole test again. Okay, so that fixed all of the tests. So with that, we finished the fourth part of the kata. These are the tips that we picked up along the way and that we used to fix our broken tests. I hope you found it useful and yeah, goodbye.